Question 4. A continuously increasing annuity with a term of n years has payments payable at an annual rate t at time t. The force of interest is equal to 1 over n. Calculate the present value of this annuity in terms of n. So right away, we can figure out that this question obviously requires an integral to be solved. So our present value ranges from time 0 to time n, and we do not know what n is. And an integral of t times e to the power of 1 minus n dt. So this does look fairly complicated, and one way to solve this is through integration by parts and allowing u to equal t and dv to equal e to the power of 1 over n. So I'm just going to jump ahead straight to the answer here. So the PV ends up being nt times e to the power of t divided by n over the range of n to 0, plus the second part of the integration by parts, which is another integral ranging from 0 to n, and the integral of n e to the power of t minus n dt. Further equals to n squared e to the negative 1 minus n squared e to the power of t divided by n, ranging from n to 0. So n squared e to the power of negative 1 minus n squared e to the power of negative 1 plus n squared, which then simply equals to the most simplified version of this answer, which is n squared 1 minus 2e to the power of negative 1. And that is how you should leave your final answer, just because it is in terms of n, and there's nothing more you can do. I'd just like to mention that when receiving a question like this on a test that is fairly complicated and fairly time-consuming because it does require integration by parts, this is the type of question that you'd read, figure out how complex it is, and just leave it for the end of the test so you don't end up wasting 7, 10, 15 minutes on something you may not even be able to solve.